Right now, I'm looking at a word problem that states, in traveling 150 miles, Paul used 21 gallons of gas. How many gallons of gas would Paul use on a trip of 525 miles? Now, this word problem is a good example of a word problem that you can solve using a proportion. When I set up the proportion for this problem, I will express the information in the form of miles per gallon. So, looking at the first part of the problem, I will underline 150 miles in red. And then I will underline 21 gallons with green. I can then rewrite this information as 150 over the quantity 21, which I will write in green. I can set this equal to another fraction that will contain an unknown quantity. Looking at the second part of the word problem, I see that we know how many miles we are traveling, so I will underline that piece of the problem in red, 525 miles, and then I will be sure to put this information in the top or the numerator of my fraction because the 525 miles over here correlates to the 150 miles over here. And then the unknown value in this particular word problem is how many gallons. So using green, I will write X in my denominator because this is the quantity that is unknown. Because when I'm looking at this proportion that I have written, I notice that my unknown value, or my variable, is in the denominator, and I think it may be difficult to isolate this variable. I'm going to use a process called cross-multiplying to solve this proportion. So when you cross-multiply, I always start off by drawing circles around my proportion like so. This states that I plan to rewrite my proportion as follows. 150 times X is equals 21 times 525. So proportions offer this unique property whereby you can multiply the two numbers here, 150, the number in the numerator on the left, by the number in the denominator on the right, and set that equal to the product of the number in your denominator on the left multiplied by the numerator on the right. So 150x equals 21 times 525. I now have an algebraic equation that I can solve using basic algebraic principles. I will begin by rewriting my equation as 150x equals 11,025. I used a calculator to simplify to find the product of 21 and 525. From here, I would divide both sides of my equation by 150. This would allow me to isolate my variable x, uncovering the value of this unknown. When I perform this operation, I discover that x is equal to 11,025 divided by 150, or 73.5. So going back to the original problem, we were looking to answer the question, how many gallons of gas would Paul use on a trip of 525 miles, using our proportion, and then using a proportion, and then solving by using this cross multiplication method. We discovered that Paul would need 73.5 or 73.5 gallons of gas.